For today's lesson, we will be discussing about theorems related to chords. Let's start with Theorem 105, or the perpendicular to a chord theorem. This states that if a segment from the center is perpendicular to a chord, then it bisects the given chord. So, we have here the word bisect, which means that the chord will be divided into two congruent parts. So to better understand this theorem, let's have an example. Let's say you have here circle A, wherein segment AB is perpendicular to segment CD. So we know that again, segment AB is perpendicular to segment CD. Now, segment CD is the chord, and segment AB is a segment going from the center to the given chord. Now, according to Theorem 105, so if the segment from the center is perpendicular to the chord, then it follows that segment AB bisects segment CD. So again, when we say bisect, that means it will be divided into two congruent parts. So it also follows that segment CB is congruent with segment BD. So these two are also congruent. This will only happen if the segment is coming from the center of the circle. Next is we have Theorem 106, the center to chord midpoint theorem. The segment joining the center of the circle to the midpoint of any chord, which is not a diameter, is perpendicular to a chord. So, if we again connect the center to the midpoint, then it will be perpendicular to the given chord. So, for example, you have here circle O, wherein we have here segment DA as a chord. And at the same time, point E is given, which is the midpoint of the said chord, which is again segment DA. Now, if we will try to connect the center, which is point O, to the midpoint, which is point E, and connect it with the segment, so we have here segment OE, then according to Theorem 106, the segment created by the center and the midpoint, which is in this case is segment OE, is perpendicular to the chord, which is segment DA. So again, the segment must be perpendicular to the given chord. Next is we have Theorem 107, the perpendicular bisector chord to center theorem. So this states that the perpendicular bisector of a chord of a circle passes through the center of the circle. We have the word here, perpendicular bisector. When we say perpendicular bisector, so it follows two things. First is, it is perpendicular to the chord, and at the same time, it bisects or divides the chord into two congruent parts. So what this theorem say is that every perpendicular bisector of the chord must pass through the center of the given circle. So let's say we have here in circle O, we have here line A, which is a perpendicular bisector of segment CD. So when we say again perpendicular bisector, so it must be like this, it must be perpendicular, it forms a right angle, and at the same time, it bisects the given segment or the chord, or it means that the chord will be divided into two congruent parts. Now, if you will see the line, it passed through the center, which is point O. So this is what the theorem states, that whenever you have a perpendicular bisector to a chord, it will always pass through the center of the given circle. Next is we have Theorem 108, the perpendicular bisector chord to central angle theorem. the perpendicular bisector of a chord of a circle bisects the central angle subtended by the chord. So again, we have the perpendicular bisector. So it forms a right angle and at the same time divides the chord into two congruent parts. Now, we have to consider here the central angle subtended by the chord. When we say subtended by the chord, that means the endpoints of the chord are also the endpoints of the said angle. So what happens here is the perpendicular bisector of the chord will also divide the central angle into two congruent parts. For example, you have here circle O, wherein we have DM as the chord, and at the same time, segment OT is the perpendicular bisector of the chord DM. So when we say perpendicular bisector, so it forms a right angle and at the same time divides the segment or the chord into two congruent parts. Now, you can identify here the central angle subtended by the chord. So if you will see point D and point M are the endpoints of the chord, and these are also the endpoints of the central angle, which is angle DOM. So angle DOM is the central angle subtended by chord DM. Now applying Theorem 108, then we can say that segment OT, which is the perpendicular bisector of the chord, also bisects angle DOM. Okay, so it will also divide the angle into two congruent parts. So you have this angle DOT and angle MOT. So it follows that angle DOT is congruent with angle MOT. So the perpendicular bisector of the chord will also divide the angle into two congruent parts. So last is we have Theorem 109 or the central angle bisector theorem. So this is just the converse or the opposite of the previous theorem. So this states that the bisector of a central angle subtended by the chord is the perpendicular bisector of the given chord. So this time what we know is we have the central angle and it has a bisector. Now it follows that the bisector of the given angle will also be the perpendicular bisector of the given chord. So to illustrate, let's use the same figure a while ago. So here in circle O, we have here segment OT, which bisects angle DOM, which is a central angle. There will be two congruent angles, which are angle DOT and angle MOT. Now from that, applying the theorem, so OT is the perpendicular bisector of the chord that subtended your angle DOM, which is segment DM or chord DM. So again, it's just the opposite. So again, OT, segment OT is also the perpendicular bisector of the chord DM. And that's it for today. I hope you learned something about the theorems related to chords and see you next time.